Hi everyone! Are you ready for lesson 1.3? Of course you are! Today we're going to work on solving equations with variables on both sides. It's so much fun! Let's get started. So your lesson objective today I will use inverse operations I will combine like terms and use the distributive property. To solve equations with those variables on both sides. So basically this lesson is taking what you did in 1.1 and 1.2 and combining it all together so that you're solving more complex equations. But we're still using those inverse operations. So example 1 is solving a basic equation with variables on both sides. And that should have an x, so I'll just add it right now. There we go. So we have 10 minus 4x equals negative 9x. I am going to draw my line. I don't have any like terms to do. I don't have any distributive property. That's why it's a basic equation. So now I need to pick a side that is going to be for my variable. When I have variables on both sides, I like to look at the amount. And I want my variable on the side that's going to give it a positive number. So we want to move the smaller number to the other side with the bigger number. Now remember, with negatives, the bigger the negative, the smaller the number. So I actually am going to move the 9x over to the other side. So my x is going to go here and everything else will go here. So inverse of negative 9x is positive 9x. I didn't do anything with the 10, so I'm bringing that down. And a negative 4x with a positive 9x leaves me with a positive 5x. Okay. Now that I've gotten my variables on the same side, now I need to move stuff that isn't a variable. So the 10 needs to move because it doesn't have an x. So we will subtract 10 on both sides. This gives me 0, which is what I want. Now I have 5x and I have 10 on this side. My final step is to get the x all by itself. Moody teenager wants to be alone. So we will divide by 5 on both sides. And we get a solution of x is equal to negative 2. There we go. All right, let's go ahead and take a look at what is called solving an equation with grouping symbols, also known as parentheses, but you could also have problems that have brackets in them. So this is just an example. We're not solving this one. So the brackets tell you need to start in there, but then the parentheses tell you need to that's your first step, is the parentheses, and then you go to the what's inside the brackets, and then you go outside the brackets. So that's what the brackets are. We don't see too many of them, but you do see them. And then you also may see those little squiggly little lines like this. Those are also brackets. So with our grouping symbols, we are looking at distributive property. And how do we distribute? We multiply, Mrs. Lee. Excellent. So we've got 9x minus 12. Okay. And then we're distributing the 1/4. Okay, so 1/4 times 32x. So that would be 32x divided by 4. which leaves us with 8x. Okay. And then 1/4 times 56, that would be 56 divided by 4, which comes out to be positive 14. All right, we've used distributive property. I'm looking at each side of the equal sign, and I am not seeing any like terms that need combining. So now we can get started. So before I pick my variable side, I want to look at my variables. This is a 9x, this is an 8x. They're both positive. Which one's bigger? The 9x. So that's the side I'm going to pick for my variable. So what needs to move here? Well, I'm going to go ahead and move the 8x, although you could start moving something else. It's up to you. 9x minus 8x equals 1x, or just x. That negative 12 stays, and the positive 14 stays. Now, before we move any farther, just want you to know that when you get to this stage of equation solving, you can start wherever you want to. You don't have to start by moving the variables. You could start by moving that. You could add 12 to both sides. It doesn't matter. We should end up with the same solution. So now that I have this, I need to move this guy over to here. Okay. So how do I do that? I add 12 to both sides. Now I have x, and 14 plus 12 is 26. So my solution, x equals 26. Here are our practice problems. So go ahead and pause the video so you have time to write down the practice problems, unless you've printed out the notes, in which case you can just use those. You can work the practice problems with me. You can pause the video, do the problems, and then fast forward so you can check your answers, whatever's going to work with you. All right, number 1 is a basic equation. I don't have any distributive property. I don't have any like terms. Okay. So before I pick my side for variables, I've got a negative 2x and a positive 3x. The 3x is bigger, so I'm going to move everything with a variable over to this side. And everything else over here. So that means I'm going to add 2x to both sides, leaving me with 5x and 10. Well, now that I have all of the x's on the x side, now I need to move this. And the inverse of positive 10 is negative 10. Okay. So now I have negative 10 and 5x. To get that x by itself, I need to divide by 5 on both sides, giving me a solution of negative 2. Now, there are some math teachers out there that are very picky, and they will mark this wrong because you're supposed to have the variable first. I am not one of those teachers. Doesn't matter to me, but just know that those teachers are out there. All right, on the second problem, let's switch colors here. We do have distributive property, so I need to multiply 1/2 times both my terms. So 1/2 times 6h would be 6 divided by 2, which is 3h. 1/2 divided by negative 4, well, negative 4 divided by 2 is negative 2. And then I have negative 5h plus 1. So I've done the distributive property. I don't have any like terms that I need to combine. So now I can solve. Okay, again, I'm looking at my variables to decide which side, which one is bigger, 3h or negative 5h. 3h. So this side is going to be for h's, this is for numbers, and I need to move that negative 5h to the other side. I do that by adding 5h. So now I have 8h minus 2 equals 1. I need to move what doesn't have a variable, this guy, I need to move it over to the other side. So what's the inverse of -2? That's +2. So I have 8h and 3. My final step, dividing by h on both, or 8, on both sides to get my h by itself. And I'm going to squeeze this in. My h is equal to 3/8. And you can leave fractions in their form as long as they are reduced. You don't have to turn them into decimals or anything silly like that. You're good. Okay. So the last piece of 1.3 is probably the most fun piece of 1.3. I'm not going to lie, it's super fun. Identifying number of solutions. So all of the equations that we've been doing have had one solution. Okay, so x equals 5, y equals -3, q equals 3/4. So all of the solutions that we've got, all of the equations we've done have one solution. And I usually abbreviate solution. I just put sol, one sol. Then it's possible that we can have infinitely many solutions. Infinitely many solutions. Now, I am fine with the abbreviation IMS for infinitely many solutions, but there are definitely math teachers out there that are insistent that you write the whole thing out. I'm not one of those. And then our final one, it's possible to have no solutions. And I abbreviate that no sol. There we go. So, looking at an equation, let's go ahead and work on solving. So I have distributive property in this first one. Okay. So 3 times 5x is 15x. 3 times 2 is 6. And that 15x. So now if I want to move things, well, 15x and 15x are the same. So I guess it doesn't matter which one I use. So I'll go ahead and say that x's are going to be here and everything else is here. So if I subtract 15x from both sides, this gives me 6 and this gives me 0. Well, 6 does not equal 0. Not even on really weird Mondays. So this is no solution. If you get a final piece that comes out to be not true, 6 does not equal 0. If you come to get that final piece right there, then you have no solution. Let's take a look at B. And I distribute. -2 times 4y is -8y. -2 times +1 is -2. And I'm noticing that they're the same on both sides. So when you get to that piece, when you have the same thing on both sides, that means that you have infinitely many solutions. Okay. And I'm okay if you stop there, but you have to have this work to show that both sides are the same. So you need to show that process. Okay. Well, if you have any questions over section 1.3, please make sure that you write them down so that you can ask when you get to class next time. Have a great day.